Um, Welcome to sort of part two. Uh, Not that the first part was a prerequisite. So just a quick poll. Who was in the session before lunch? Cool. All right. So there were a few that were not, and that's totally fine. So as part of this, we'll do a very brief review of some of the core concepts that we covered earlier today, just to make sure that no one gets left behind. But if there's something that I gloss over that leaves you completely like, what is he talking about? Raise your hand and ask, and we'll go through. I don't want to go over things too quickly, but at the same time, for the people that were in earlier, I don't want to bore them to death with too much in-depth review. So for those that weren't in the first session, so my name's Russ Hamm. I work with a company called Intelligent Medical Objects, and we do terminology and terminology software solutions. So we implement content and software in order to make EHRs easier to work with, do decision support, expert system implementations, and we leverage software and terminologies to do that. I'm a software developer by background, computer science, background in operating system development, and then about 16 years ago got into the terminology space and really fell in love with it because it's a great way to just really open up the medical record, encode content using terminologies, and then build systems that use that content to do really cool and exciting things. So I've been working with terminologies for well over 15 years, terminology software, and have been involved in the health level 7 space for about a decade and a half. So, which kind of frightens me because I got a 16-year-old at home. It's like, when did that happen? I guess 16 years ago. So some of the things I do on the side, I've been co-chair of the HL7 vocabulary work group and continue to be so on the technical steering committee and infrastructure steering committee. So just trying to drive the HL7 standards forward and support FHIR as best we can. Just want to thank everyone in the FHIR community, the HL7 community, my fellow co-chairs, all the terminology people that we work with. Really, it's a really great collaborative group. We all get along and we argue like family, and it's been a great group of people to spend the last decade and a half with. So, outline for today. I was a little slide heavy, so based on the last session, and so what I did is I did take some things out, but I want to tell you what those are because I'm here through Friday, and so if there's interest, we can talk about that because I'm going to be here all week. What we cover today, we're going to do a quick review of the FHIR terminology module. So we'll just take a look at the core concepts that we covered earlier, just to kind of set the stage for the rest of the talk. Then what we're going to do is talk about how FHIR resources use terminology. So a couple different ways terminology specifically supports FHIR resources. And then we'll talk about an example. We'll take an example of a condition resource and show how a terminology server can actually be used to validate and do some interesting things with terminology as part of an example. So I do have slides for that, but what I'd prefer to do is switch over to my web browser and actually run some queries live, and we'll just see how that works. So you can actually see how a terminology service can be used in real time. And the one thing that I didn't mention that I did take out, which we can talk about all week if there's interest, is just some applications that sort of the idea of a FHIR terminology app in the wild. So some real world applications of terminology and FHIR resources. So I did pull those slides out because I was a little slide heavy and I wanted to make sure I got through the core material. But if there's interest, today, tomorrow, Friday, and you're interested in seeing some of the ways that FHIR and terminology can be used in real world EHR integrations, I would just love to talk about that. So, all right, so some of the basics. So we talked earlier today about how terminologies provide the conceptual framework to unambiguously identify data. So the example I used at the end of last class, got the CrossFit coach coming out of me, everything's a class. Last session was that if you receive the letters MI as part of a medical record, how do we unambiguously know what MI stands for? You know, is that mitral valve insufficiency, myocardial infarction, or did somebody just put the patient's state of Michigan in the wrong field? So because we can code data, this allows us to unambiguously identify that MI actually stands for myocardial infarction, which in the SNOMED CT code system would be 222.98006. So when you start memorizing these things, you've been around the industry a little too long. And it's the tuple, it's the code system identifier, URI, along with that 222.98006 that identifies that concept as the identifier for the concept myocardial infarction in SNOMED CT. And that concept is going to have associated it'll have properties associated with it, it'll have a body site associated with it, it's going to have associations. So myocardial infarction is going to be a parent of acute myocardial infarction, which will be a child. It's a little more specific. Myocardial infarction is a child of cardiac disease, which is a parent. And so we have relationships between these concepts that allow us to infer information. And you can walk the hierarchy, and you can walk the hierarchy down and up to either get more specific and say, is this is cardiac, what type of condition is a cardiac disease? Or you could go down and be more specific. So terminologies allow us to consistently represent data and consistently exchange data. And then we use terminology services to query that information out and manipulate terminologies. So we have a set of operations that we can call software services, RESTful in the case of FHIR, that allow us to query content in a consistent way. And this helps us ensure that when I say I have validated that this code exists in the SNOMED CT code system, you have some degree of confidence that I know what I'm saying, and I have a degree of confidence that you know what you're saying. So when you receive a code and say, yes, I validated using this operation that this code is in fact myocardial infarction in SNOMED, we have an understanding that a shared understanding of what it means to validate that. So terminology services support that. Again, quick review, FHIR terminology module here. So FHIR supports the use of terminologies through the following terminology model. So here we have the idea of a code system that defines a set of concepts. We have value sets. In the case of SNOMED, with over 300,000 concepts, we probably don't want to use all of them at once. And so we can subset that by creating a value set. And a value set is essentially a definition that when you execute the expand operation on that value set definition, it's going to return to you a set of concepts. And it's that set of concepts that you're actually interested in, even though the value set itself is persisted as an expression. So give me all types of cardiac disease. Boom, there they all are. And so our code system is composed of concepts, and our value set is a selection of concepts from a code system, and then FHIR resources bind, they use this binding, a FHIR resource can specify what content is allowed to be assigned to a coded attribute, and that's done through binding. Code system resource, again, is really just essentially a set of metadata. We talked about that just on the previous slide. The value set selects codes from one or more code systems. I can select from SNOMED and ICD-10 if I choose to. So I can combine two different code systems, content from two different code systems to create a set of codes for some purpose. So example, heart failure problem patient cohort. So I can identify a set of problems that would put a patient in the heart failure cohort. Code systems have codes. So codes of reference are referenced through a code system. We have three ways of, I thought I hid this one, 3 ways of specifying coded data in FHIR. We have code, which is really, it's a primitive data type. It essentially says that we specify the code in the attribute in the FHIR resource. The system is implied, so we can just actually specify the code because the resource itself tells us what values are allowed. Coding, complex data type. Here we have our tuple. So we use a code as well as a code system to uniquely identify the meaning of that concept. So that's http://snowmed.info/sct. That's the URI that identifies SNOMED. And then we have our 222980006 to identify myocardial infarction, or 2225300 to identify pain. If you have a terminology server handy, you can look that up and see if I'm right. And then lastly, we have codable concept, another complex data type. In this case, we have multiple coding elements. So this tuple here, we can have multiples, which allows us, we also have the ability to add plain text and descriptions. So we can actually put in myocardial infarction, the actual human readable term, because most sane people don't go around memorizing SNOMED codes. So by actually being able to put that description in there, we can, it's not necessary because you can go to a terminology service and look up the actual human readable description or the synonymy, so it's not required, but it's kind of friendly to do so. It saves somebody the step of going out and querying it. And then binding. So binding is the way that we attach coded values to FHIR resources. So a binding identifies what codes are allowed for a given element. Bindings have different strengths associated with them. So we have the idea of required. So if a FHIR resource has a codable concept or a code element, we can bind by using the coding strength required that says codes shall come from this specified value set. So we have a value set defined, it's got 3 or 4 concepts in it, and we can say that the strength on that binding is required. Thou shalt use these codes in order to be interoperable and compliant. No other options are allowed. We have the idea of a binding strength of extensible, which says you shall use the code from this value set if it applies. You are free to use other codes if the one that you need isn't covered by the value set. So if the value set isn't complete for your purpose, you're allowed to extend it and still be conformant. But if there's a available code in there that covers your use case, if it says you shall use the SNOMED code for myocardial infarction, you can't then go and select the ICD-10 code for myocardial infarction because that concept is covered by the scope of that value set. We have a preferred binding strength. Codes in this element should be from the value set to support interoperability. So in order for us to exchange information and be interoperable, we should use the same language, but there's no requirement to do so. And then lastly, example. An example binding is just, these codes are only here for example. They're not even recommended for use. It's just for example purposes only. So you can specify the strength of the codes that are allowed to be applied for a given FHIR element. Code system references. So referencing code systems, this allows us to again to unambiguously track back to the original definition. So it allows us to understand that MI from the US states code system specifies the state of Michigan, MN being Minnesota, what have you. FHIR specifies, I actually kind of like this list here. The system or code system reference is determined through this following ordered list, which I really like when when this was added to the FHIR terminology module specification, that the specification in the code system registry, and there's a URL here, and these will be posted, but this is actually from the FHIR spec. If the code system's in here, you shall use it. This is one of those shall verbs. Otherwise, if it's not in this list and the code system publisher specifies a URI or an object identifier, that's what that OID is, that's the one you should use. So if you're the code system publisher, you kind of have the right to say which reference someone should use. It is your code system after all. There is a FHIR community code system registry, which actually works really, really well. And then lastly, catch-all is the HL7 OID registry or object identifier registry. So kind of a nice ordered list that tells you if you're looking to reference a code system in you're building a terminology-enabled FHIR application and you need to reference a code system, this ordered list provides the sequence of resources that you need to look through. I'm going to skip this one. This is really just how to reference codes. The codes and resources are referenced in the FHIR specification itself. It defines sets of codes that can be used in FHIR resources. They can be pulled from HL7 version 2 tables or HL7 version 3 code systems. Look at this, I'm not even skipping it. You can pull them from external terminology resources like SNOMED or LOINC, value set distribution sources like the Value Set Authority Center in the US. You can also pull them from local interface terminologies. Interface terminology being a very fine-grained terminology typically used at point of care. It gives the granular detail that a clinical professional needs to specify to get the level of specificity they need to specify a condition for a patient. So examples, so the condition resource, here we have 8 different, and yeah, I know it's small, I apologize. I used to not complain about that, but I just got my first set of progressive lenses this year, and yeah. So 8 different elements in the condition resource support coded data. Next. Come on. So we have clinical status, we have verification status, category, severity, so how severe the condition is, the actual code itself, right here, body site. Note that they're all optional. And then, body site is, that one's, that's patient who has the condition. That one's not optional. You need patient, right? Code for summary, and then any evidence. The evidence here, that's for staging, and then evidence can also be coded. So 8 different elements in condition actually support coded values. Terminologies can be used to enhance searching for FHIR resources, and this is actually really cool, something that we're looking to, in some of the apps that we've been building, some of the later versions of them that we've specified are going to be supporting this. So you can, using a token or a parameter and a modifier, enhance the ability to search through FHIR resources using these different parameters. So these are actually really interesting. You can have here parameter code. So if you have the code parameter, this allows you to specify, give me the FHIR resources that match a coding or identifier irrespective of the value of the system property. So if there's a code, give me all the FHIR resources that have the code 222-98006. So give me all the condition resources that have that code in there. So if that code's there, you're going to get a whole bunch, hopefully. Hopefully everyone's healthy enough and they're not having myocardial infarction. So, but it does happen, and so you're going to receive a list of resources that have that code in there, irrespective of the value of the system property. So if there's another code system out there that happens to have that same series of characters, 222-98006, Even though it's not SNOMED, you're going to get that too. So it might not be myocardial infarction, it could be something else. You can specify the code and system. So if you put the code and then the system URI for SNOMED, you would only get the resources, the condition resources for myocardial infarction. Show me anything from SNOMED or LOINC. Give me anything. Give me all conditions where there's a coded value from SNOMED CT. I'm not sure how. I mean, it's interesting to know. I'm not sure where that's going to get you, but it's possible to query it. And then lastly, give me any code or identifier where the code matches with no system property specified. Yes, sir.
LOINC has several versions, one each half year. Can you identify the version of the LOINC that you want?
Yes.
If you want huge subsets, then that would be.
That's right. So code systems can be versioned. And so in the system property, you could specify the version as part of that, or for the system parameter, and then that would constrain that to a specific system. Same with with the value set version as well. Excellent question. So how to access specific versions of value sets. Now that's all cool. So you can return a bunch of stuff that's a little more specific, but it would be cool if we could get even a little more specific. And that's where we can actually modify these parameters. And so what we can do here is we can do things like modify using the below modifier. And this is one that gets a lot of play. Give me the resources with the coding that's subsumed by that code. So if I were to specify the SNOMED CT URI, so I'm working with SNOMED, and I specify the URI for cardiac disease, because myocardial infarction is a cardiac disease, it's part of that sub-hierarchy, I'm going to receive that. I'm also going to get acute myocardial infarction. I'm going to get all the different types of heart disease. So that's where you can get very specific. Show me all patients with diabetes, all the patients that I have that have diabetes. And so any subtype of diabetes is going to be swept up in that query. You can specify as well, give me all the resources with a specified code that is in this specific value set. So the value set could have 3 things in it. The value set could have 30 things in it. It could have, well, the example I used today was a nutrition status. There's 134 concepts in it. Show me, return to me any resource that has any of those concepts in the nutrition status value set. That's starting to get a little cooler, actually. You can actually start getting very specific with your resource queries. Alternatively, you can search for not in. So show me resources where the coding is not in the specified value set of specific types, resources with a parameter of system code and value in the specified value set. Modifiers of text as well. We haven't implemented that one in our search yet, in our searching as of yet. Resources that do not have a matching item. And then lastly, just like we have that below, so show me all the things that are below all the types of cardiac disease, we can also look above. And so show me all the types of, all the resources that have a concept that is a parent or ancestor of a given concept. So you can look up as well. Just a couple examples, just to drive the point home. Search for any patient with a gender where the code is male. So we can do a get with patient gender equal male, bang, there's all our male patients. Search for a condition of lateral epicondylitis, my nemesis earlier in the year from too much barbell work. And so that's get condition code, and then I specify snomed.info/SCT, and then the code for lateral epicondylitis or tennis elbow. And again, here's our subsumption one here. Condition code is below, and here I've specified the code for neoplasm of liver. So that's going to get me any descendant, any resource that is that or a descendant of. So let's follow an example through. So here we have, we've received a patient that has a condition resource attached that describes a patient with a diagnosis of recurrent moderate lateral epicondylitis. I'm just beating this example to death because, you know, I'm familiar with it, right? So the following optional coded concept attributes are populated. So remember, the coded values are optional, so we get 3 back. So how do we validate and manage the supplied coded values? What do we do with them once we get them? So they gave us, someone went through all the effort of actually encoding this data. Now what? So one of the first things we're going to want to do is validate that these things are actually real. So actually validate that the coded values from the external code systems actually exist. These are actual coded values from the external code system, but then also validate that the FHIR value set data is also real. So how do we go about doing this? So this is where I'm going to switch over really quickly. Okay, I hope this plays well. If it doesn't, we can go back to the slides. So first thing we want to do here is we're going to want to validate that the code from condition code, the actual lateral epicondylitis is actually real. So what we'll do is we can do a quick call out, and this takes like milliseconds to do for a server. It takes me a lot longer to talk through it and explain it, but we're going to hit a terminology service. We're going to pass in input, and what we're going to do is validate that that code 202.855.006 from SNOMED is actually real. So what we can do, I'll hop over to a terminology service. This is one of many terminology services available. This is a FHIR service. So we're going to go to code system validate code, because if it's not a real condition, we're going to have to go down an error handling path of some type. If you sent us data that's not valid, we're going to have to deal with that some other way. We're not going to throw out the message, but we're just going to have to do something different with it. So I'm just going to scroll down to code system validate code. So what we're going to do here is we pass in our URL for SNOMED, and we're going to pass in our code. I should have worn my new glasses. SNOMED.info/SCT. And then we will execute it, and we'll see what the results are. And this is not a production environment, so the performance is not reflective of what we typically get. And there we are. All right. So what we get is the result is true. This does exist. And we actually also display the, return the display. So this is disorder, and it is lateral epicondylitis. So there we go. We've actually made that call. We've confirmed that this is real. On to the next step. Moving right along, and this is the backup plan. So next, now that we validated it, what we can do is we can look it up. So we validated that the sucker is true, but we want to know some more details about it. You know, we know this display name, but really that's all we know about it at this point. So what we can do is go to code system lookup. There we are. Again, there we have our code. We know it's valid. We specify the system. Try this guy out. That's a little better. All right, now we have a list of stuff returned to us. So I'm going to hop over to the next slide just because it's black on white, and it's a little easier to read. So we have here, we know it's from SNOMED. We know the version. So there's our version identifier for the version of the code system that it came from. Here's the display value, lateral epicondylitis disorder. It also returns to us synonymous terms, so a set of synonymous terms associated with that concept, as well as the fully specified name for it. Okay, so that's all great. So we know we have our code. For that condition, we know it's coded, we know it's valid, we got additional information about it. If we want to do any other decision support on that, or run it through an expert system, or maybe there's a clinical guideline that has been encoded or a best practice that we can then send that information to and get additional real-time support from a decision support system or a best practice system. Next thing that said was severity. Severity was specified, and this is actually, condition severity actually comes from a FHIR defined value set. And so let's go ahead and verify that one. In this case, we're going to use the value set validate code operation. So again, we're going to authenticate to the server, and then we're going to do the same sort of type thing where we're going to specify the identifier for the value set, in this case condition-severity, the code for that, and the system that the code comes from. So in this case, the FHIR condition resource specifies a value set called condition severity, and there are a set of codes in that value set that are pulled from the SNOMED code system. So let's go ahead and try to validate that. Head over to our value set operations. And this is just our Swagger interface over top of our terminology server. So that's kind of the interface that we have built over top of it. One of our developers got bored at an HL7 Connectathon and actually wrote a custom UI that with drop downs and did some really nice filtering, and then we made him throw it out in favor of Swagger. So here we specify our condition severity, so the ID of the value set resource, and we'll specify here the code, and we'll specify the system. And assuming I typed it in correctly, we can validate this. Give it a second to churn. And this is all happening ideally in, all these validations are happening pretty much immediately. So we get our result back. And then here are the parameters. We have, false. What did I do? 202. Oh, I messed that up because it should have said true. Let's see if I made sure I typed the URL correctly. Maybe I actually grabbed the wrong one. So let me well, call me a liar. The demo gods are not in my favor. It should have said true. It should have actually existed. So I'm going to have to debug that because that actually worked when I made the slide. So assuming that had worked correctly, we confirm that condition severity exists so that we know that the patient has moderate, that was supposed to be the code for moderate, epicondylitis. Oh wait, no, that was the wrong code. Here we go. Look at that, Come here, code. 6736007. Get the right code, it should work. There we are, true. I knew it. Hide from me. Okay, so we know that's true. We know it works. So then we can actually take it a step further. What we can do here, so here is just the value set. If we actually query that value set, what we can see here is there are 3 codes: severe, moderate, and mild. Oh, spelling mistake. I'll have to bother my reviewers about that. I still take blame for it though. So these are the three codes um, in that value set, and here is moderate, and here is, yep, these are, so if I actually went and looked up that code, this isn't all of them, if I actually did a lookup on that code from the code system, here's the fully specified name, moderate, severity modifier, it's a qualifier, here's the synonym for it, again, here's the version of the code system. So we're actually can query out and get all this great information from the terminology server. Okay, so what? We validated a bunch of stuff. What's the big deal? Well, that's really the first step. Once you know that you actually have validated the codes, you have a condition resource, you know all the content are valid, this is where the fun begins actually. This is what gets me out of my bed and in my desk in the morning, is the next steps. So at this point, you can then start updating the electronic health record with this information. You know it's valid. You can start adding it to the EHR. You can start doing things, especially in the US, in terms of billing. So now we're going to take that. We're going to look at billing options for that, sending that information perhaps to an insurance company for reimbursement. We can do some other things like use knowledge from the codes, like the actual description logic from the code system, to do further analysis. So we can actually use the subsumption to make inferences about that. So, you know, is lateral epicondylitis a soft tissue disorder? We can use the terminology service to look up treatment options, to generate, you know, pull information from clinical guidelines and best practices that we've implemented in our system to help guide at the point of care. Drug-drug interaction type things. You don't want to like overload the toxicity on the liver by prescribing two of the same types of drugs, or maybe two opiates, what have you. So yeah, best practice alerts. You know, non-steroidal anti-inflammatories apparently are contraindicated in some cases for lateral epicondylitis, at least according to my physician, who told me to stay off the ibuprofen. But I read papers to the contrary, doctor, and he told me just to shut up because he knows his job and I don't. So that's kind of where the fun begins. It's doing that initial validation that gets you to the point of the, you know, searching for the resources, collecting the resources, validating the coded values in those resources, that then gets you to the point where you can start really having fun and building expert systems that actually work and process on this data. So that actually gets me to the end. I think I have less than a few minutes left before we're done. So I'm happy to actually take questions like I did. I did cut a bunch of slides out on real world stuff, but I think it'd be more appropriate to talk about that, you know, outside anyway. Take a look at some real world FHIR apps that are being using terminologies specifically to do some really cool things. So I'm here all week. Any questions?
I have one more question.
Yes, sir.
A couple of months ago, I needed codes from a few code systems which weren't in FHIR yet, like the Human Phenotype Ontology and Orphan and Rare Diseases. And there's quite a bunch in bioportal, biomedical ontologies, which aren't there yet. So how do I go about? Because I don't invent my own system names, of course.
Right, right. We were talking about this a little bit at break as well. So the question is, if you have a need for a code system that's not in FHIR right now, or there is no ID for it, how do you go about getting that? I'm trying to think of some of the solutions that we were coming up with. There's a process through FHIR to try to get them added, but if and that's part of the harmonization process through HL. Is that through FHIR or is it through? I'm asking Rob.
It depends. I mean, whether we're talking about external versus
External.
and they don't necessarily need to go to harmonization if they're adding it. So typically we would just add it if it's appropriate for the core spec. We could
Have it.
get it added.
Right.
But
So
we're trying to get away from that. We're trying to have terminology
Okay, so Rob's comment was we're trying to move away from having terminologies, or having terminologies separated from the specification. Um, are these code systems, so they're developed externally and published?
Yes, yes, yes. Human phenotype ontology is academic stuff. It's basically phenotypical features which you have when you have a disease. So people with rare diseases, they might have a malformed oracle. So you have code for a malformed oracle. And the orphan has rare diseases have a whole lot of codes which aren't in SNOMED yet. So they're on a harmonization effort. But the last 2 years, I don't think that it has moved very
Do they
quickly.
already have a defined URL for it? I mean, you can, if they do.
Yes, yes, those are all biometrical ontologies.
Yeah.
On the Over Foundry, the Python BioPortal, they have their own URIs.
So we've done some work mapping. We've done HPO specifically, and so HPO is distributed as an OWL ontology that builds on about like 100 other OWL ontologies. So
Yes.
that's one of the complications when you map OWL to FHIR code systems is that you have to do cross code system subsumption, which FHIR doesn't really support. And so that's tricky, but yeah, there has been some work. We've certainly got HPO and FMR and a whole bunch of those rare disease and cancer ones. Typically, genomics people typically.
Yes, yes, and it's an adjacent area. It's
Yeah.
quite close, and it's used a lot in data sciences.
So
and
there is some
healthcare.
work, and I know there's been some discussion, particularly about code system URIs on hash genomics on the FHIR chat.
Yeah.
And I know HPO has been one of those specifically.
And,
There is work.
and there is no requirement that the URI be resolvable. It
No.
just needs to exist. So even,
Yes, yes, yes.
Yeah,
Yeah.
it's really a community effort to agree on what it should be, and ideally that is led by the publisher of the stuff.
Right.
If they don't care about FHIR, then we can make what we think is a sensible decision.
That's one of the problems. Of course,
Yeah.
I can pick, I think it's ajax.apo.org or something, but if FHIR later decides it's slightly different, then I've messed up.
Yeah, and we've even had that. I think we picked something from inside the alpha that we thought made sense, and then we talked to someone else who was also using it, and they picked something slightly different, which also made sense. And so it's just a matter of the early adopters working through it, agreeing until we get to a point. And if it's something that's widely used, then we could put it on the spec page as an
Yeah,
agreed
right.
URI,
Right.
or in some central registry. But, yeah. So there is.
excellent question. Good discussion, so thank you. All right. Looking forward to talking with everyone throughout the week and getting to know you, and appreciate your time today.